Now it's a pleasure for me to welcome Ralf Dömkes. He is Business Unit Executive Rational for the German-speaking part of Europe from IBM. And he will tell us a little bit more about the activities of IBM, well known as an IT company in the embedded space. Please go ahead.
Yes, thank you very much. Embedded software itself doesn't make sense. So embedded software is more and more embedded into mechanical and electrical or electronical systems. Without these, embedded software makes no sense. So we see these products all over the space. So being in automotives, being in household goods, being in a mobile phone, and all these single units are more and more connected. So you connect your mobile phone to your automotive, the automotive itself communicates internally, and so the single products where embedded software is running develops further to a cyber-physical system, and if all these stuff is going to integrate and communicate over the internet, we are at the notion called system of systems or Internet of Things. What we are offering here is an entire tool and methodological set to develop those very, very complex systems, starting with the single product development, where you can model and develop single products, but also which gives you an overview and a structure for a broader view of these products, including the mechanical and electronical view. So it's not only about software development, but Rational and IBM are providing tool sets and methods for developing the broader products, and even till the extent of cyber-physical systems, where we can see how this all interacts and integrates together. On the other hand, we are working together with our colleagues from Global Business Services and the software group services people to educate people on our tool set, on the methods, so that they can apply them in a customer context to do consulting work and bring a customer with these new methodologies and these tools to a new form of embedded software development.
And that you said cyber-physical systems. Does it include you help your customer to develop the application of the whole system, or is it just the system you are helping to develop your customers? Is the application included? If you have a cyber-physical system in a car, so you have an ECU, and this ECU is controlling, for example, the brakes. Does your software include the brake function as well in the whole system, or is this the task of your customer?
So we are developing, or what we are helping the customer to develop is one step above. So we are providing specific tools for software development, while other vendors like Mentor Graphics or Siemens or PTC are developing the similar tools for electronic design or PLM. What we are providing is one step above, a tool which integrates, or which enables the integration between all these different vendors to get a unified view of all the artifacts which are used in such a system, and which need to be viewed as an integrated system to do the testing, the quality assurance, and to get an overview, especially also in the sense of traceability. If I change requirements in the mechanical part, what needs to be changed in the software or in the electronic part. So we leave the specialist tools to the specialists which develop them for quite a while, adding the embedded software development and put one layer on top.
You mentioned other vendors as well. So IBM is well known as a very closed company in the future, no, in the past too, excuse me. Will this stay for the future as well, or do you open yourself, or the company is opening up itself to the market and to standards and things like this? Because when you work with different vendors and so on, you have to interact with them?
We are clearly opening up because especially in the embedded space or cyber physical system, and even go further to the Internet of Things, we have so many tool vendors and people providing methodologies, so that we need to integrate. We can't do everything by ourselves. So the strategy is clearly to set on open standards, which are not IBM standards, but coming from a community. The main standard we are setting on is OSLC, Open Services for Lifecycle Integration or Collaboration, which we use to integrate our tools internally, which is the easy part. Yep. But again, using this also to collaborate and integrate with all other systems or tool vendors, which provide their tool for the other domains, which I talked about before, so that we then, if I'm going back to this overall or this upper level, that we can integrate PLM, mechanical parts with electronic parts, with the software, and setting all the linkages and the integration we need for the overall view.
You said PLM, that another explanation or another word, ALM. What is the difference between these both?
I would say PLM is usually perceived as doing something with mechanical parts. It's more about the design of machines and not so much about software. And this is where ALM comes into the play. So ALM means Application Lifecycle Management. And most of the machines we are seeing today, predominantly in the automotive space, are controlled by software. So the software part within PLM becomes more and more important. So we need to integrate ALM into the entire PLM lifecycle. So integrating it not only by the tools, but also by the methodologies, so that software development becomes an integral part of the entire PLM lifecycle, because products not only consist of mechanical parts, electronic, but especially of software, which is usually which is becoming in recent times the main differentiator of products when they sell to the market.
Okay, thank you very much.
Okay, my pleasure.